Next question of exercise 2.2 is write the following in the simplest form. The question is question number 5. Tan inverse under root 1 plus x square minus 1 upon x, where x is not equal to 0. For this, if x is equal to 0, then the value of this thing will be undefined. Now before we proceed for the solution, you need to concentrate here, because this 1 plus x square comes under the square root. So by trigonometric substitution over here, we will try to remove this square root. Now for the removal of square root, before we proceed for this particular question, I let you know about all the laws which we will be using later in this chapter also, and later also for almost all the polynomial expressions which falls under square root. So for that you need to understand this thing. For example, rule for substitution. For example, if like this question only, under root 1 plus x square, if the variable, you need to remember this thing, if the variable comes in positive manner and the square, it will be square only. You need to take care of that, whether it is positive or negative. If it is positive, then you that like this, under root 1 plus x square, or it can be under root x square plus 1. Then you will be substituting either tan theta or cot theta. X is equal to tan theta or cot theta. Why? Because in general trigonometry you have identity number 2. The identity number 2 says sec square theta minus tan square theta is equal to 1, and cosec square theta minus cot square theta is also equal to 1. So because it is 1 plus x square, so we will do it, we will transfer this tan square theta to the right hand side, so it will be 1 plus tan square theta. So when it is something like that, 1 plus x square, that is our target. So we will substitute x is equal to tan theta, so then this will become 1 plus tan square theta. These two terms, algebraic terms, will be converting into single term, sec square theta. Then this square and this square root will cancel. Then we will have only sec theta outside, and then we will proceed like that. Or if it is cosec square theta minus cot square theta is equal to 1, then it is also equal to 1 plus, just like above, cot square theta, and it is nothing but cosec square theta. So you can substitute this either or this one. Clear? Okay. The next type is, if this square root, this under root x square minus 1, this was 1 plus, constant is also positive and variable is also positive in this case, but in this case the constant is negative and the variable is positive. Then in this case, what you will be substitute, or it may be minus 1 plus x square, both are same only. So in this case you will be substituting x is equal to sec theta or cosec theta, just like previous this identities. What were the identities? Like as I told you, sec square theta minus tan square theta is equal to 1. So what we are going to do, instead of this taking tan square theta that side and adding 1 into this, we will take this 1 to the left hand side. So it will become sec square theta then this 1 will come to the left hand side, so it will be minus 1 equals to this minus tan square theta will go to the right hand side, so this tan square theta. Now look at here, this x square theta minus 1, this is x square minus 1 is something like that, x square theta minus 1, or this thing x square minus 1, both are same thing. So when we substitute this x by sec theta, we will have sec square theta minus 1, which is equal nothing but tan square theta, and this square root will cancel with this square, and then we will have simple tan theta. So you understood, first term, type is both are positive, second is constant negative and variable positive. Now the third we may have where the variable is negative and the this constant is positive. So in this case we will substitute like first identity, sin square theta plus cos square theta is equal to 1. So we'll substitute here x is equal to like y, because sin square theta plus cos square theta equals to 1. So in this case we may have the value of sin square theta is equal to 1 minus cos square theta. So it is something like that, 1 minus cos square theta means what? 1 minus x square. So we'll substitute this one. So now we'll go for this using all these concepts here. So we'll go with this first one. Is our question is like identity, this substitution of type first. So we'll substitute this like the question is tan inverse 1 plus x square minus 1 upon x. Put x is equal to tan theta, as we have this one. X is equal to tan theta. Very simple question. So then theta, this tan, taking tan inverse both sides, so tan inverse x is equal to theta. So theta is equal to tan inverse x. That will be, we will be using at the end of the question. So now tan inverse outside, then 1, then plus x square means tan square theta, and then minus 1 is outside, and then denominator x again substituted by this tan theta. So here it is tan theta. So tan inverse, like I told you, 1 plus tan square theta will become under root sec square theta, and then that square will cancel with this square. Then we have simple sec theta minus 1 upon tan theta is this one. Next is tan inverse. This sec theta is 1 upon cos theta minus 1 upon sin theta upon cos theta. So we have taken LCM over here. So 1 minus cos theta in the numerator, and this denominator cos theta and cos theta cancel. So we will have 1 minus cos theta upon sin theta here. Now tan inverse, here we have written 2 sin square theta. Now you need to remember this particular thing. Identity, we have, what is that identity? Since cos 2 theta formula we have is equal to 1 minus 2 sin square theta. Now if it is 2 theta, then here we have single theta. If it is single theta, here only coefficient is 1, then we will have 1 minus 2 sin square theta upon 2. Okay, so this actually in place of this cos theta, we have used this 1 minus 2 sin square theta by 2. So now when this 1 minus, this will also become minus when we will multiply this minus inside, and this will become positive. So this minus and this minus cancel, so we have 2 sine square theta by 2. Now it is equal to this tan inverse outside and 2 sine square theta by 2 from here, as I explained you. And this instead of this sine theta, now you remember that identity, that formula, sine 2 theta is equal to 2 sine theta cos theta. So instead of sine 2 theta, now we take sine theta only, then formula will be converted like this: sine theta by 2 and cos theta by 2. This sine theta will be 2 sine theta by 2 cos theta by 2. So 2 sine theta by 2 here and cos theta. 2 and 2 cancel. Sine 1 power is removed this with 1. And now we have sine theta upon 2 and cos theta upon 2. Sine upon cos, tan theta by 2 here, which is nothing but is equal to tan and tan inverse removed. So we have theta upon 2. Now from here the value of theta is tan inverse x. So this is equal to half, means this one 1 by 2, this one 1 by 2, and tan inverse x means this theta, value of theta is equal to tan inverse. That's all about this. This is called the simplest form of this question. Clear? So now the next question is question number 7 again. Tan inverse 1 minus cos x upon 1 plus cos x. Same formula what we learned, cos 2 theta is equal to cos square theta minus sine square theta, that we will be using once more in a different format. So tan inverse, the question is under root 1 minus cos x upon 1 plus cos x. Tan inverse, now this cos x, as I told you like previous thing, 1 minus the value of, this is bracket, the value of cos x is, we have put 1 minus 2 sine square x by 2. So in this case, now this 1 and 1 cancel and minus into minus plus. So sine square x by 2. 2 sine square x by 2. This is the numerator. And in the denominator, we have put cos x is nothing but 1 is outside plus the value of cos x in that format is 2 cos square theta by 2 minus 1. This is for cos x in terms of cos x. This is for cos x in terms of sin x. Now this 1 and this 1 can. Here we have 2 cos square x by 2. Now 2 and 2 cancel and sine upon cos tan x and tan square x by 2. So square and square root will cancel, and then we will have tan inverse square of this cancel because of this square root, and this square is also removed. So sine x by 2 upon cos x by 2, which is nothing but tan inverse tan x by 2 here, and then tan and tan inverse removed. So we have simply x by 2. That is called simplest form of this question number 7. The next question is 8. This is also very simple question. Tan inverse cos x minus sin x upon cos x plus sin x. So for solution, tan inverse, same thing, question we have taken. Tan inverse dividing numerator and denominator by cos x. So here we have cos x, here also cos x, here also cos x, here also cos x. Numerator and denominator divided by cos x. Cos x and cos x cancel. In denominator also cos x and cos x cancel. So 1 minus sin x upon cos x and 1 plus sin x upon cos x, which is nothing but tan inverse 1 minus tan x upon 1 plus sin upon cos x tan x. Now this is identity in inverse trigonometric functions. Tan inverse 1 and tan inverse x. I tell you how we get this tan inverse 1 minus tan inverse tan x because of this formula. Tan inverse x minus y upon 1 plus xy. This we get if tan inverse x minus tan inverse y, or vice versa. Now look at here. If we have here x, then the first term is x. If we have here y, then the first term is y. Then in the denominator 1 plus the multiplication of both. So here we can write 1 into tan x. Now look at here, x minus tan x, for example, yeah, x minus y upon 1 plus x into y. For that, tan inverse x. Now instead of x we have here 1. So tan inverse 1 minus tan inverse y, the second one. Second one is tan inverse x. I hope you understood this. Tan inverse 1 minus tan inverse tan x. That is tan inverse x minus tan inverse y. So this is nothing but equals to pi by 4 minus x. How it is? I explain here. This is tan inverse 1. When this tan gives you one value, when it is tan 45, pi by 4 degree. So in this particular case, tan and tan inverse removed, so you will have pi by 4. And in the second case, tan inverse tan also removed, and then you have tan inverse x only. So in second case, tan inverse and tan removed, so you will have minus x. So pi by 4 minus x. That's how you got this one. Clear? Next question, tan inverse x upon a square minus x square. Now here it is something like that 1 minus x square, but the constant here in this particular case is not 1. Otherwise simply we could have put sin x or cos x for this. So let us see what we should put. Put x is equal to a sine theta, a times sine theta. Why did, if it had it 1, then we could have put here nothing 1 into sine theta, but since here a, we have a, so here also we want this a, so that these both a's can be taken out of this square root. So we put a sine theta. Why? Let us see next step. Then this would be x will go to the left hand side, and then x upon a is equal to sine theta. This implies theta is equal to, this will go to this side, taking sine inverse both sides. So sine inverse x upon a is equal to theta. This value we will be putting at the end. Then this tan inverse x upon a square minus x square is nothing but tan inverse. Now x is what? A sine theta. So we put a sine theta here, a square, and a sine theta here, a sine theta. Now its square is there, so a square sine square theta. Now we'll take this a square common, and then its square root will come out of the square root as a, so that will go outside. So a sine theta as it is in the numerator, and this a square we have taken common, so its square root is a outside this one. This a and this a cancelled. So we will have tan inverse sine theta upon under root 1 minus cos theta, this cancelled. Under root 1 minus sine square theta is cos square theta, this one, and then that square and square root cancel, so it will come out as cos theta. This is equal to tan inverse and sine theta upon cos theta, tan theta. Tan inverse and tan removed, so we will have theta only, and the value of theta we have here, this one. So this is theta is equal to sine inverse x upon a. This is simplest form of our question. Next question is, find the values of each of the following. So now the question of the simplest forms are over now. So we have to find out the value. Value means we have to solve, and what we are getting at the end. So the tan inverse 2 cos 2 sin inverse 1 by 2. Looks complicated, but very simple thing. Sin inverse, let sin inverse 1 by 2, this much only, sin inverse 1 by 2 equals to x. So this implies sin x is equal to 1 by 2. Sin x is equal to 1 by 2. So this is equal to sin 1 by 2 when it gives at 30, sin 30 degrees, sin pi by 6. So instead of 1 by 2 we can write pi by 6. So sin inverse actually 1 by 2, that was x, and we got it is equal to pi by 6. Sin and sin removed, so x is equal to pi by 6. Now x is what? Pi by 6. So we put here x is equal to pi by 6. Sin inverse 1 by 2 pi by 6. Now this value we will put here. Now tan inverse, the question is tan inverse 2 cos 2 sin inverse 1 by 2 equals to tan inverse 2 cos as it is 2 into this sin inverse 1 by 2 is equal to pi by 6 from here, pi by 6. Okay, so now this 2 3s are 6. So tan inverse 2 cos pi by 3. Now cos pi by 3 is 1 by 2. So tan inverse 2 in this value of cos pi by 3, 1 by 2. 2 and 2 cancel. So tan inverse 1, when tan gives you 1 value at 45. So tan inverse, we will write it as tan inverse tan pi by 4. This tan pi by 4 for 45 degree, and this tan inverse and tan removed, so we will have pi by 4 only. That is called the value of this question. The next question, 12th, is cot tan inverse plus cot inverse A. Solution: cot tan inverse A plus cot inverse A. This is identity like we wrote earlier. Sin inverse x plus cos inverse x is equal to pi by 2. Sec inverse x plus cosec inverse x is equal to pi by 2. In the same way, tan inverse A plus cot inverse A will be equal to pi by 2. Since tan inverse x plus cot inverse x is equal to pi by 2, therefore cot pi by 2. Since tan pi by 2 undefined, so cot pi by 2 will be 0. That's all about this question. 12th is over. Now we'll move towards the next 13th question. 13th number, tan 1 by 2 sin inverse 2x upon 1 plus x square cos inverse 1 minus y square upon 1 plus y square. This is an interesting question. You need to concentrate in general trigonometry that if we substitute this x by tan theta, 2 tan theta upon 1 plus tan square theta is the identity, is the formula of sine 2 theta in terms of tan theta. And if we substitute this y, so again with the tan theta, so 1 minus tan square theta upon 1 plus tan square theta is again formula of cos 2 theta. Okay, then let us go for it. So x is equal to, let's put x is equal to tan theta here. As I told you, this 2 tan theta upon 1 plus tan square theta will become sine 2 theta. So for this then theta is equal to, here this will go that side, means taking tan inverse both sides, so tan inverse x, and then from above sine inverse 2x upon 1 plus x square, this one will be equal to sine inverse 2 tan theta upon 1 plus tan square theta. As I told you, this is formula for sine 2 theta. So this is equal to sine inverse and sine 2 theta, and sine inverse removed, so 2 theta, and theta is equal to tan inverse x, so is equal to 2 tan inverse x. Similarly, let us suppose y is equal to this, for y is equal to this y equals to tan phi, then phi is equal to tan inverse y. This phi is equal to taking tan inverse both sides like this. So phi is equal to tan inverse y. Then from above, cos inverse 1 minus y square upon 1 plus y square equals to cos inverse. In place of y we have supposed tan phi. So 1 minus tan square phi upon 1 plus tan square phi. Now this is equal to cos 2 phi. So equals to cos inverse cos 2 phi. Now the cos and cos inverse removed equals to 2 phi. Now phi is equal to tan inverse y. So equals to 2 tan inverse y. Now we have got the simplest forms of these two, 1 and 2. Now we'll go for this question, then we'll solve this. So that is tan 1 by 2 sin inverse 2x upon 1 plus x square plus cos inverse 1 minus y square upon 1 plus y square. That is our question. So the value of this and then value of this cos inverse we are going to put here. So tan 1 by 2, its value is 2 tan inverse x, value of sin inverse 2x upon 1 plus x square, and similarly cos inverse 1 minus y square upon 1 plus y square equals to tan this 2 taking common to outside, and then this 2 cancel. So tan is outside here, and then tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy. Then tan and tan inverse will remove so equals to x plus y upon 1 minus xy. That's all about this question.